Hi, today we are looking at section 4.4, which is combining transformations of functions. So we'll be combining the translations as well as reflections and compressions and stretches all together today. So combining stretches, compressions, and translations, a graph of y equals AF of B x minus h plus k is our image of y equals f of x after the following transformations and translations. So we have a vertical or stretch or compression by a factor of a. If our a value is negative, it's going to reflect over our x-axis, so that would be a vertical reflection. A horizontal stretch or compression by a factor of 1 over b. And if b is negative, it's a horizontal reflection, so over our y-axis. A horizontal translation of h units, so shifting it left to right by h. A vertical translation of k units. Now, original point x comma y is now given by x over b plus h comma ay plus k. Okay, so for example, given a graph of y equals f of x, graph y equals negative 2f of x minus 2 minus 3. So to do these, I tend to do a multi-column table of values. So I will actually do 4 columns. So original x and y. So we have this point at negative 2, negative 0.5. We've got negative 1, negative 1. We also have this point at 1 comma 1. 2, 0.5. We have a horizontal asymptote at y equals 0. And we have a vertical asymptote at x equals 0. So next we'll find our new points. So in doing so, we'll use that point equation. So that's x over b plus h and ay plus k. So our first thing is figure out where our values are. So if we've got negative 2 here, that's our a value. We don't have a number in front of this x, so b is technically equal to 1. Takes the form of x minus h, so h is positive 2, and then k is equal to negative 3. So we have x over b, our b was 1, so x over 1 is just 1. Then we've got plus h, so plus 2. Our a was negative 2 times our y value minus 3. So take our x values, figure out our new ones. So we had negative 2 plus 2 is 0. Negative 1 plus 2 is 1. 1 plus 2 is 3. 2 plus 2 is 4. It's horizontal asymptote we weren't worried about. Our x values for vertical one, we've got 0 plus 2, so that's going to be 2. So I might as well draw in that vertical asymptote now. and label it. So we have a vertical asymptote at x equals 2. Now we'll look at our y values. So we have negative 0.5 times negative 2, that'd be 1. 1 minus 3 is negative 2. Next, we have negative 1 times negative 2 is 2, minus 3 would be negative 1. Next, we have 1 times negative 2 is negative 2, minus 3 is negative 5. Next, we have 0.5 times negative 2, so that would be negative 1, minus 3 is negative 4. Then we've got 0 for this horizontal asymptote, so negative 2 times 0 is 0, minus 3 gives us negative 3. And we won't calculate the y value for vertical asymptote. So we'll draw in our horizontal asymptote, which is now at negative 3. We will label it. And then we'll plot our new points. So at 0, we're at negative 2. 1, we're at negative 1. 3, we're at negative 5. 4, we're at negative 4. So our new graph looks something like this. Okay, next example, use a graph of y equals the square root of x to graph y minus 2 is equal to root of 3x plus 3. So first thing I would do is just take this equation and rearrange it. So we've got y minus 2 equals root of 3x plus 3. I'd move the 2 to the other side by adding 2 to both sides. Now that's outside of our root, so we've got y is equal to root of 3x plus 3 plus 2. Now I can factor 3 out of these, so then I can actually get my b value. So I've got equals square root of 3 times x plus 1 plus 2. Okay, so looking at this, our a value, we don't have a number in front, so it's just going to be 1. Our b value is this 3. Our c value is negative 1. Or sorry, that should be our h value. And our k value is positive 2. So once again, I'll do a multi-column table of values. So we'll write down our original points. So at 0, we were at 0. 1, we were at 1. 4, we were at 2. And if we continued on at 9, we would have been at 3. Okay, so our new x is given by x over b plus our h value. So x over b minus 1. Now our b value in this case was 3. And then this one's ay plus k. Our a was 1, so we just have y plus our k value, so plus 2. Okay, so first one, we've got 0 divided by 3 is 0, minus 1 is negative 1. Then we have 1 over 3 minus 1, so that'd be negative 2/3. Then we have 4 over 3 minus 1, so it'd be 1/3. Then we have 9 over 3, which is 3 minus 1 is 2. Look at our y value, 0 plus 2 is 2, 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5. Okay, so we'll start plotting these. So at -1, we are at +2. -2/3, we are at 3. 1/3, we are at 4. And then 2, we are at 5. So our new graph looks something like that. Okay, so next we're looking at writing the equation of a function after transformations. So we want to write the equation for image in the form of y equals AF of B x minus h plus k. To do that, what we want to do is find two corresponding points on each graph. So we'll find a minimum that corresponds on each graph, and for example, a maximum that corresponds on each graph. And then what we're going to want to do is get our horizontal and vertical distances between those. To get our value of A, we divide the image's vertical distance by our original graph's vertical distance. To get our B value, we divide our original horizontal distance by the image's horizontal distance. And then we pick corresponding points on the two graphs and use our x over b plus h, comma ay plus k to help us figure out h and k. Okay, so given the graph of y equals f of x, which is our graph that's in black, we want to determine the equation of our image, which is our one that's in blue. So first thing I want to do is find some corresponding points. Now, typically when we do that, we label them with the same letter, but just add something additional on our corresponding graph. So for example, I could say that this is A, this maximum here, which will correspond with this one. So we'll call this A prime, which just has this little extra symbol here. And then we'll choose one of our minimums to be B. So for example, this one here could be B, which this one corresponds to it. So this one is B prime. Now, like we mentioned, we want to first start by figuring out our horizontal and vertical distances. So looking at our original, so A to B, horizontally, our B value had a final x of 0, so we have 0, minus our initial x, which was A, so minus -2. So our horizontal distance was +2. Our vertical distance, once again, we'll take our final vertical location, which is in this case -8, and subtract our initial vertical position, which was 0. So vertically, we had a change of -8. Now we'll do the same thing for the corresponding distances on our new graph. Okay, so B prime, our x value is 2. And then we'll subtract our x value from A prime, so that would be 0. So that would just give us 2. And vertically, we ended at -8, and we subtract our starting point of +8. Now, like we mentioned, our A value is our new vertical distance, which will be -16, over our old vertical distance, which was -8. So our A value is going to be 2. Our B value is our old horizontal distance, which was 2, divide by our new horizontal distance, which is 2. So our b value is 1. At this point, what we're going to do is take our coordinate equation, so x over b plus h comma ay plus k, and essentially split that into two separate equations. So we know our new x is equal to our old x divided by our b value plus h, and our new y is equal to our a value times our old y plus k. So if we substitute in what we know so far, we have x new is equal to x old over 1, which is just 1, plus h. Our y new is equal to our a value of 2 times our y old plus k. At this point, we'll choose points. So for example, I will use a and a prime. We have to use points that correspond. So our a is at negative 2 comma 0, while a prime was at 0 comma 8. So we'll use those in these equations. So our new x value was 0. Our old x value was negative 2 plus 8. So we'll move for 2 to the other side. So 2 is equal to our h value. We'll do the same thing with this one. Our y new was 8. That's equal to 2 times our y old, which was 0. Plus k, so we have 8 is equal to k. So now we'll write out our equation. So we know our equation takes the form of y equals a f of b x minus h plus k. We'll just fill in our variables. So y equals a, which was 2. F of, we don't have to put our b in because there's 1, so we just have x minus our h value of 2 plus our k value of 8. So this would be our final equation.